At 2:37 a.m., a major retailer's payment system goes dark, credit card terminals beep error, online checkout throws a 500 error, and every passing minute hemorrhages revenue. One misconfigured server did all that. Today, you're going to learn how to build infrastructure that doesn't fail and how to turn that skill into a six-figure career. By the end of this lesson, you'll be able to do three important things. First, you'll understand the major components that make up enterprise IT infrastructure and how they work together. Second, you'll be able to explain why technologies such as virtualization, networking, storage, cloud services, automation, and monitoring are essential for modern businesses. Third, you'll understand how these technologies support careers ranging from systems administration and cloud engineering to infrastructure architecture. The goal isn't to memorize product names. It's to understand how enterprise technology works as one connected system. Enterprise IT infrastructure is the collection of hardware, software, and networking that runs a large-scale business. Think of it like the power grid behind every digital service a company offers. It's not one server in a closet. It's the servers, storage, virtualization layer, operating systems, and business applications all working together. This stack is what lets a bank process thousands of transactions a second and a retailer survive Black Friday without crashing. Enterprise infrastructure spans both physical boxes you can touch and virtual components you spin up with a command. Physical means real servers in a data center with cooling and power. Virtual means a hypervisor slicing that same hardware into isolated virtual machines. The cloud blurs the line. You still depend on physical servers, they just belong to Amazon or Microsoft now. The biggest misconception in IT is that moving to the cloud removes physical hardware. It doesn't. It shifts ownership. Enterprise servers are built for non-stop operation. But raw compute is worthless without storage that's equally resilient. That's why enterprise storage layers on technologies your laptop never touches. RAID combines multiple disks so a single failure doesn't lose data. Snapshots capture a point-in-time state, letting you restore a database immediately after a fat finger mistake. Replication continuously mirrors data to a secondary site. So if the primary site burns, the business survives. And the crown jewel, a storage area network, or SAN, delivers block-level access over a dedicated high-speed network, the kind of performance that handles thousands of transactions per second for a hospital's patient database. These aren't optional extras. They're the foundation of reliable infrastructure. Let's pause for a quick knowledge check. A hospital needs storage for a mission-critical patient database that must remain available even if a disk fails. Which technology provides block-level storage designed for high performance? A. Direct attached storage. B. Network. Attached storage. C. Storage area network. The correct answer is C. Storage area network. SAN storage provides high-performance block storage used by many enterprise databases and virtualization platforms. It is commonly combined with RAID, snapshots, and replication to improve availability and recovery. Networking connects every part of an enterprise. When you open a website, your request typically travels from your computer to a switch, then through a router, across one or more networks, through security devices such as firewalls, and finally to the destination server. Each layer has a specific responsibility. A switch connects devices within a local network. A router moves traffic between different networks. A firewall evaluates traffic based on security rules. Even a small configuration mistake, such as an incorrect VLAN assignment or firewall rule, can prevent users from accessing business applications. That is why networking requires careful planning, testing, and documentation. Virtualization allows one physical server to host many independent virtual machines. A piece of software called a hypervisor divides the server's hardware into isolated environments. Each virtual machine behaves like its own computer, with its own operating system, applications, storage, and network configuration. Instead of purchasing 20 separate physical servers that spend most of their time idle, organizations can often consolidate many workloads onto fewer physical systems. Virtualization improves hardware utilization, simplifies management, speeds deployment, and forms one of the foundations of today's cloud platforms. Buying your own server rack costs serious money before it ever serves a request. The cloud alternative is infrastructure as a service. Virtual machines that start at very low per-hour rates for small instances. But cloud doesn't eliminate infrastructure work, it moves it up the stack. You still choose instance types, configure network security groups, and control costs. The skill that becomes incredibly valuable is managing those virtual layers with code. And that's exactly what we're building toward. And when you choose cloud storage, you're picking between storage types too. Direct attached storage is storage directly connected to a server. Network attached storage provides file-level sharing over the network. And a storage area network delivers high-speed block storage for databases. Understanding these will matter when you architect solutions. Let's lock in what we just covered. You're the infrastructure architect for a hospital's database. Your choice of storage directly impacts patient safety. Pick the wrong one, and an outage means lost access to medical records. Take 10 seconds, then check your answer. As businesses grow, their infrastructure must grow with them. One option is vertical scaling. That means adding more CPU, memory, or storage to a single server. This approach works well for some applications but has practical limits. The second option is horizontal scaling. Instead of making one server larger, additional servers are added behind a load balancer. The load balancer distributes incoming traffic across multiple systems. Many modern cloud applications use horizontal scaling because it can improve availability and make it easier to handle sudden increases in demand. Different applications use different scaling strategies. Understanding when to use each approach is an important infrastructure skill. A trading firm's main power line goes dead at 2 p.m. Not a single transaction is lost. How? The UPS, uninterruptible power supply, batteries kick in instantly, the diesel generator fires up within seconds, and operations run for another 8 hours until grid power returns. That's high availability. Enterprise infrastructure is designed to survive failure, not prevent it. Redundancy is everywhere. 2 independent power feeds from different substations, 2 separate network paths, so a cut fiber doesn't isolate the building. Server clusters that instantly fail over if a node crashes. If your disaster plan is, "We hope it doesn't happen," you're already in trouble. Enterprise means expecting failure and building so well that users never notice. Imagine managing 10 servers by logging into each one individually. Now imagine managing 1,000. That approach simply does not scale. Enterprise IT relies on centralized management and automation. Configuration management tools such as Ansible help administrators apply consistent settings across many servers. Monitoring platforms collect health information from the environment. Cloud management portals provide a central place to manage infrastructure. The goal is consistency. Instead of making hundreds of manual changes, administrators define the desired configuration once and apply it repeatedly. That reduces repetitive work, improves reliability, and makes large environments much easier to manage. A hospital stored patient records on a file server without encryption. A single stolen laptop triggered a HIPAA investigation and fines that can reach millions of dollars. In enterprise infrastructure, security is not a checkbox at the end. It's baked into every component. From switch access control lists to database encryption, from transport layer encryption to immutable backup copies, security is mandatory. And it's not just technology. Compliance frameworks like HIPAA, the Health Insurance Portability and Accountability Act, PCI DSS, Payment Card Industry Data Security Standard, and SOC 2, System and Organization Controls 2, define exactly what you must protect and how you must prove it. For your IT career, knowing these requirements makes you interview-ready because every company with sensitive data needs someone who can translate regulation into infrastructure. Enterprise monitoring helps IT teams identify problems before users begin reporting them. Monitoring platforms collect information about servers, applications, storage, networks, and cloud resources. Dashboards display the current health of the environment, while alerting systems notify engineers when something unusual happens. Different organizations use different products. Examples include Grafana, Prometheus, Datadog, Splunk, Azure Monitor, Amazon CloudWatch, and many others. The important idea is not memorizing tool names. It is understanding that successful IT teams continuously measure the health of their systems instead of waiting for failures to be reported. Here is a scenario. A company's website suddenly becomes unavailable. Should an infrastructure engineer immediately restart the server? Not necessarily. The first step is to gather information. Is the server running? Is the network available? Is the application responding? Has storage filled up? Did a recent configuration change introduce the problem? Good infrastructure engineers troubleshoot methodically instead of guessing. They investigate one layer at a time until they identify the real cause. This tiny Terraform file replaces 15 minutes of clicking through the AWS console and guarantees that every server is identical every time. Infrastructure as code means you define your servers, networks, and storage in a declarative language, store it in Git, and let the tool provision everything. Want to spin up an identical environment for testing? Run the same file. Want to make sure nobody fat-fingers a firewall rule and opens your database to the internet? You review the pull request before it's applied. Terraform is idempotent by design. Run it repeatedly, and it converges on the same declared state without creating duplicate resources, preventing configuration drift. Cloud engineers who master this skill are in high demand. With experience, they can earn well into six figures, sometimes above $130,000, because they deliver speed, consistency, and safety that manual operations can't match. A single misconfigured server can cost thousands per minute in downtime. Configuration drift, servers slowly deviating from a known good state, is a leading cause of outages. This Ansible playbook eliminates that chaos by declaring exactly what state every server should be in. The tool enforces that state, and if anything drifts, it's corrected on the next run. This concept, idempotent code-defined infrastructure, underpins DevOps, automation and collaboration between development and operations, and site reliability engineering, applying software engineering practices to operations. For roles like systems engineer or SRE, writing playbooks like this is table stakes. You stop babysitting servers and start engineering them. What happens when disaster strikes? Many companies that lose their critical data without a recovery plan are at high risk of never reopening. That's why enterprise infrastructure revolves around two numbers: RPO, recovery point objective. How much data can you afford to lose, measured in minutes or seconds, and RTO, recovery time. Objective, how quickly must you be back online? If your RPO is the last backup that someone remembered to run last week, you're gambling with the company's future. A serious DR plan includes automated replication to a secondary site, regular failover testing, and immutable snapshots that ransomware can't touch. Hope is not a strategy. Enterprise infrastructure offers many different career paths. Help desk and desktop. Support professionals often begin by learning troubleshooting, operating systems, networking, and customer support. Systems. Administrators manage servers, storage, virtualization, backups, and identity services. Cloud engineers design and manage infrastructure running in cloud platforms. Infrastructure engineers build scalable, highly available environments. As you gain experience with automation, cloud platforms, networking, virtualization, security, and infrastructure. As code, new career opportunities become available. Compensation varies widely based on experience, industry, location, certifications, and responsibilities. The most valuable professionals are those who can design reliable systems, automate repetitive work, solve complex problems, and communicate effectively. Time to prove you absorbed those automation scenes. You just used Terraform to deploy 20 servers. They're up, but they're blank. No web server, no config. What tool enforces the state you actually need, and why does it matter even after provisioning? The short answer: configuration management. Terraform gets the infrastructure built. Ansible makes sure every server looks exactly the same every time. No drift, no surprises. That pairing is what turns a sysadmin into an engineer. One of the biggest misconceptions about cloud computing is that physical infrastructure somehow disappears. It doesn't. Every cloud service ultimately runs on real servers, storage systems, networking equipment, and data centers. The difference is ownership. Instead of purchasing and maintaining the hardware yourself, you rent computing resources from a cloud provider. You still choose virtual machine sizes, storage performance, networking, security settings, and many other technical decisions. Understanding the underlying infrastructure helps you make better cloud architecture decisions. Cloud computing builds on traditional infrastructure. It does not replace the need to understand it. Let's see every piece in motion. A shopper clicks buy. DNS translates the domain to an IP. A CDN serves product images from the nearest edge cache. The traffic hits a firewall, then a load balancer distributes it across a fleet of 20 virtual machines. Inside a VM, a container runs the cart logic and fetches order data from a high-performance SAN database, all in under half a second. Break any one link in this chain, and you've got an outage. That's why enterprise infrastructure doesn't skip a layer. Every server, application, firewall, database, and cloud service produces logs. When something goes wrong, those logs become one of the most valuable sources of information. Instead of checking individual servers one at a time, Enterprise logging platforms collect information from many systems into one searchable location. That allows engineers to investigate problems much more quickly. Organizations use many different logging platforms, including the ELK Stack, Splunk, Azure Monitor, Datadog, and cloud-native logging services. The important skill is learning how to search logs, recognize patterns, and connect events across multiple systems to identify the root cause of an issue. Before we go deeper, let's untangle the storage triple threat, DAS, NAS, and SAN. Direct attached storage is just a disk plugged into one server, fast but siloed. NAS, network attached storage, adds a file-level share over standard Ethernet, perfect for department file shares but not built for insane IOPS. SAN, the storage area network, delivers raw block-level access over a dedicated high-speed fabric. That's why databases hammering thousands of transactions per second lean on SAN. The difference between file level and block level is the distinction you'll be tested on, and it's the difference between a slowdown and a crash. Final storage speed round. Heavy database transaction load. NAS or SAN? The answer, SAN. It provides block-level access. The database server treats it like a raw disk and controls the file system directly, skipping the overhead of NAS's file-level layer. More IOPS, less latency. If you said NAS, you'd choke performance on day one. Interviewers love this question because it separates people who just read slides from people who understand infrastructure. The fundamentals you learn today don't expire. AI training now demands massive GPU clusters, each node a powerhouse server with specialized networking. IoT pushes processing out to the factory floor, edge infrastructure running on ARM chips. And 5G requires latency so low that companies are putting server racks physically closer to cell towers. But underneath every one of these trends is the exact same stack: servers, storage, networking, virtualization, and automation. Master the basics, and you ride every wave instead of getting swallowed by it. Let's bring everything together. Enterprise IT infrastructure is much more than servers. It includes hardware, networking, storage, virtualization, operating systems, cloud services, monitoring, automation, backup, security, and disaster recovery working together as one connected platform. Successful infrastructure is designed to remain available, recover from failures, scale as demand grows, and protect business data. Finally, automation is changing how infrastructure is managed. Instead of configuring every system manually, engineers increasingly define infrastructure and configuration in code, making deployments more consistent, repeatable, and easier to manage. Those concepts form the foundation for modern cloud engineering, platform engineering, site reliability engineering, and enterprise architecture. Next up in Part 4, we'll trace how DNS and BGP turned isolated server rooms into the internet we rely on. But don't just wait. Right now, go back to that Terraform snippet at 17 and retype it yourself. If you get stuck, I've put a free Terraform quick start in the description. Then drop a comment. Which layer, physical, virtual, or network, surprised you most? I read everyone, and it helps me build the next deep dive. This week, build your first infrastructure diagram. Draw a simple environment that includes a user, the internet, a firewall, a load balancer, 2 web servers, a database, shared storage, backups, monitoring, and a cloud provider. Then trace what happens when a user opens a website. Which systems process the request? Where could failures occur? How would redundancy keep the application online? This exercise will help you think the way infrastructure engineers do, by understanding how individual technologies work together as one complete system. Go build something. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.